During this seminar we will be covering a short background of national ventilation, the history of Part F and L and how it is currently, various ventilation systems within Part F and any design considerations, and then any questions you may have. National Ventilation are based in Boroughbridge on the outskirts of Taunton in Somerset. Historically, building regulations across the United Kingdom were combined, but this has now changed and we have each constituent country having their own version of the building regulations. England were the first to publish theirs latest building regulations. We expect the other countries to follow shortly after, which each having finished their consultation period and looking to publish their documents soon. This was a 2022 document, so theirs are now out and active. So this presentation is from 2022, but still current. All right. Moving on to the building regulations, specifically Part F for ventilation and Part L for conservation of fuel and power. We will be looking at Volume 1, which applies to dwellings such as residential. There is also Volume 2, which applies to buildings other than dwellings such as commercial. The new 2021 edition of Part F, L and O take effect on the 15th of June 2022 in England. This means any new applications following the date will need to meet the 2021 edition. Any applications made prior to that date will be applicable for 12-month grace period, which ends June 2023. Following this, each individual plot must follow these regulations in order to comply. Historically, building regulations applied to each site or development of multiple houses. The history of Part F. Part F of the building regulations were introduced in 1992, with a version made in 1995 which added utility rooms. It stated that new dwellings must have mechanical ventilation installed within wet rooms, which are defined as kitchens, bathrooms and toilets. Ventilation of choice back then were intermittent extract fans. Fans that were turned off via a manual switch and allowed the moist and stale air to be extracted, with air being replaced by infiltration and background ventilators, trickle vents. This is not only applied to new build developments but refurbishments. It's good practice if building control is involved. The minimum extract rates meant that generally, to suit the application, 100mm diameter fans were used in bathrooms and toilets, and 150mm fans were used in utility rooms and kitchens. In 2006, Part F introduced continuous whole house ventilation systems and became more focused around performance. There were now 4 different types of systems that would meet compliance. Intermittent fans and background ventilators were known as System 1. Passive stack, known as System 2. Mechanical extract ventilation, known as System 3. And finally, mechanical ventilation with heat recovery, also known as System 4. Part L, conservation of fuel and power, was also introduced and gave rise to the fan system having a minimum specific fan power. Starting the drive to energy efficient systems, Part L was split into L1A for new builds and L2A for refurbishments. In 2010, Part F was updated to include reference to the Domestic Ventilation Compliance Guide, which introduced the requirement for commissioning of systems and compliance documentation, creating a more stringent process for ventilation. Part L, heat recovery efficiencies were increased, minimum SFP targets were lowered, pushing for further energy efficient systems. Alongside this, there were also industry guides and good practice guides to ensure compliance and best practice was followed for installations. With the introduction of the 2021 edition, the main focus is health and energy efficiency, which we see as a positive moving forward following COVID-19 pandemic. The regulations look at minimise entry of external pollutants, ensuring humidity and pollutants are extracted effectively and efficiently, and setting minimal levels of fresh air to ensure good occupancy health. The approved documents reference a number of industry guides, codes of practices and standards published by organisations such as CIBSE and BRE. Approved Document F interacts with other approved documents. Part B is also about fire safety. This applies to ducting and penetrations through walls and fire structures. Part B also gives guidance on escape windows and openings. These may well be larger than those required for ventilation in Part F and should take precedence. If in doubt, consult the fire officer. So what that's basically saying is the fire officer will overrule Part F if he wants something different. Interaction with Part J, combustion appliances and fuel storage systems. Part F cannot supersede Part J. When permanently open air vents are required for combustion, as ventilation fans might cause combustion gases to spill from open fluid appliances. Interaction with Part K and M, which covers protection from falling, access and the use of buildings, which states that controls should be within reasonable reach of occupants. And finally, Part O, which covers overheat. This is a new approved document introduced in December 2021. This can impact the purge ventilation rates, which may exceed those found within Part F to manage the rapid dilution of pollutants. The higher the two standards should be followed. Part O is probably something you guys have dabbled with or heard of or may have had to get involved in. I can elaborate a bit more on it afterwards because it's quite a hot topic at the moment with consultants. Right, so we're going to move on to approved document Part F, which is the main one around ventilation. The various ventilation systems within Part F are no longer classified between 1 and 4. Earlier I mentioned about systems 1 through to 4. They've abolished the numbering of the systems and they've gone back to just giving them a name now. On the left, property on the left, we have a natural ventilation, previously known as System 1, background ventilators and intermittent fans. Fairly common practice. In the middle, we have a continuous mechanical extract ventilation, previously known as System 3, continuous mechanical extract ventilation, an MEV. That's a centralised version on the drawing, so one unit ducts off to various different areas. And finally on the right, we have mechanical ventilation with heat recovery, previously known as System 4, continuous mechanical supply and extract with heat recovery, MVHR. So there are the three types prescribed ventilation systems, with passive stack being removed. Other system types such as positive input ventilation, known as PIV, may be used to comply, but expert advice should be sought. So PIV can be used on a new build only if the structure cannot physically have one of the main three. Building control may allow PIV to be a means of fresh air in. In the drive to reduce energy consumption of buildings, focus has been around improving the fabric insulation levels, reducing heat loss through ventilation and increasing the building air tightness. How airtight the building is has an impact on the energy use, and these changes to the guidance introduce the requirements that all buildings must be air tightness tested. Yet again, not a new thing, but something that's being looked at and managed more. Air tightness is important as it helps ensure the energy that's used within the property is retained. As you can see from the thermal image, which compares a well-insulated and airtight house showing the blue on the right side with a less insulated house, standard house in the background, which is showing more heat radiation and leakage on the left. Note the brighter colours than the house on the foreground. The minimum air tightness of a building is 8 metres cubed per square metre at 50 pascals, reduced from 10 in the previous guidance. If air tightness is greater than this, the building will not comply. If a dwelling is designed with natural ventilation, tests as highly airtight, which is a air permeability of 3 or less, expert advice should be sought. Or a continuous mechanical extract ventilation system should be installed. Continuous mechanical extract ventilation is for between 5 and 3, CMEV centralised and DMEV decentralised. And anything below 3 should be MVHR. The graphic here shows the value at which the building changes from less to highly airtight, which varies depending on whether it's a as-built or design air permeability. This will be dictated by the consultant of the build, the designers of the build, what they want to work towards. They should be dictating to you guys what they want you to install based on their design. It's not always as easy as that. Sometimes it's a bit of an open book and they kind of lean on you guys and go, speak to a manufacturer, they'll design it, sort of thing. But in an ideal scenario, they'll have all of that data for you. The minimum intermittent and high extract rates between 2013 and 2021 editions remain unchanged and are presented within table 1.1 and 1.3. For intermittent extract systems, there are 60 litres or 30 litres for a kitchen, 30 litres for a utility, 15 litres for a bathroom and 6 litres for a toilet. So if the cooker hood in that property is going out to atmosphere, it can be 30 litre. If they can't get it out to atmosphere and it's a recirculator, you need to put a fan in that is 60 litre to comply. Most manufacturers do them. They're not usually pretty. They're not quiet because you're shifting 60 litres a second. It's a lot, but it doesn't replace extractors. They should still be providing a carbon filtered extractor, but that's not a Part F thing. It's nothing to do with you. It's nothing to do with you. But you need to know, if you're going into a property and you see a carbon filter and they tell you to put a 15 or a 30 litre in, really you should be going, I can't put that in, I need to put 60 in. And you wouldn't believe the amount of contractors that aren't even aware there's a 60 litre, aren't aware they need to put a 60 litre in, and they've just been putting 30s in for God knows how long. And it's not the contractor's fault, no one's policing it, no one's signing it off. But that you're going to start seeing that getting ramped up. It already is, it will continue to get ramped up. A significant change within Part F is the whole dwelling ventilation rates, which have been increased. When applying the whole dwelling ventilation rates are to be taken from table 1.3 and selected depending on the number of bedrooms within the dwelling. For every additional bedroom, there is a requirement to add 6 litres per second. Don't stress too much about this, we would be doing this for you. So we'd just give you the numbers, you don't need to work this out necessarily. These new figures are based on 2 occupants in a master bedroom and 1 in a subsequent bedroom. In addition to these changes, the minimum ventilation rate should not be less than 0.3 litres per second per square metre of internal floor area, including every floor. The higher of the 2 values calculated should be used. If the whole house rate exceeds the high extract rates, there is no specific requirements for boost speeds to be increased above the whole house rate, but dependent on various factors such as a lifestyle, you should consider minimum of plus 10% boost. Also to note, 1 habitable room, for example, a bedsit or studio would fall under 1 habitable room and would need a minimum ventilation rate of 13 litres a second. So what that's basically saying is if we're designing an MVHR system and you give me a kitchen that's the size of this room, much bigger than a standard kitchen, it's what's going to be needed to change in there is far greater than Part F. So our calcs would supersede the 13 litres that Part F is telling you. So you might think that you've got to do 13 litres at the air valve, but we're saying no, you've got to actually do about 30 because of the size of the room. But we would design that and other designers would design that for you. Another thing just to be mindful of, that percentage increase on whole home systems, what that means for you guys in real life is back in 2010 you'd have been using 4-inch ducting. Because of this percentage increase, what would have been okay on a 4-inch is now probably a 6-inch. So for you guys installing it, that's a lot more headache. So be very mindful when someone just casually goes, yeah, chuck MVHR in that house for me. Because of the increases in flow rates for a whole house, it's big kit. So just be careful how you quote your jobs, because contractors very often come unstuck by assuming it can be done on some tiny little bit of kit, and it can't. Mechanical ventilation systems in regards to approved document L are largely unchanged, but continue to specify that systems should be designed to minimise electric fan power, which is called specific fan power, and should not be worse than shown in the table. Specific fan power is calculated by dividing the wattage of the fan by the duty rate in litres to give you the watts per litres rate. The only change here is the heat recovery efficiency, which was originally stated to be a minimum of 70% within a building services compliance guide, and is now 73% as of 2021. Just for your knowledge, 73% is achieved by every manufacturer's heat recovery system, so everyone's far exceeds that. There continues to be a requirement to have summer bypass and variable speed controller for summer and extract ventilation systems within SAP. Natural ventilation with background ventilators and intermittent extract fans, known as System 1. Intermittent extract fans should be fitted in all wet rooms, and correctly sized background ventilators, also known as trickle vents, be installed and sized correctly. Here is an animation of a natural ventilation, as you can see as part of this animation. Extract rates are unchanged, but key points to be aware of. If a wet room has no external wall, the fan should extract up to 4 air changes per hour in order to meet the purge ventilation standards. It should be noted that for larger wet rooms, this may exceed the minimum extract rate. For example, an internal bathroom of 15 metres squared would need a minimum intermittent rate of 16.7 litres a second. So because of the nature of the room, it exceeds what Part F's asking. An automatic control such as humidity control should have a manual override to allow occupants to turn the extract ventilation on or off. And if no window is present, the fan should be provided with controls which continue to operate for at least 15 minutes after the room is vacated. Background ventilators are now defined by single story or multi-story. There is a 20% increase in area for habitable rooms and a 60% increase in area for kitchens. Fans and background ventilators should be at least 500 mm apart if installed in the same room. And if any external facade faces an area of sustained and loud noise, an attenuating background ventilator is needed. To attenuate a fan that backs onto a railway line or an airport runway, you wouldn't be able to do it straight through a wall because an attenuator is a metre long. So that would only work if you was able to mount a fan in the middle of the ceiling and have a duct run, and then be able to fit an attenuator in between the joists before you get out. So it's not just as easy as just attenuate a fan. What we're finding is any build happening near a railway line or an airport is just MVHR. They're stopping people having trickle vents and stuff to stop any noise coming in. A key note to be aware of is that background ventilators are not recommended in dwellings with only one exposed facade, or if a dwelling has at least 70% of its openings on the same facade. This will mean that apartments will likely need to move towards mechanical extract ventilation or mechanical ventilation with heat recovery. If there is a habitable room that does not have any windows, you will need to ventilate through another room. In order to comply with this, there should be a permanent opening between the two rooms of at least 1/20th of the combined floor area of the two rooms. Background ventilators of at least 10,000 millimetres squared equivalent area, purge ventilation should be present. It's quite a lot. That's quite a lot of stuff to actually do there. It's in the regs. We can help you design it if you get caught with one of them, but trickle vents have got to be right, the opening's got to be right, the ducting system's got to be right, and what it is usually down to is someone, a landlord, has taken a bedroom and turned it into 2 bedrooms, but there's only one window and it's in 1 bedroom or something like that. So, yeah, again, whether it's policed or not, or even if building control even aware of that, is a different matter. A system for purge ventilation is required in each habitable room to remove high concentrations of pollutants from occasional activities, for example, paint smells. Purge ventilation should be capable of extracting a minimum of 4 air changes per hour per room directly to the outside. 4 air changes in a standard bedroom is probably a 6-inch fan. That's the reality of it. So it's, well, when we get on to part O, you'll be quite gobsmacked. Where purge ventilation is delivered through openings such as windows in a habitable room, the minimum opening areas, which are specified in table 1.4, should be achieved. There are minimum changes when compared to the 2010 edition, where previously it distinguished between doors and windows. These have now merged into the table known as 1.4. Purge ventilation applies to all ventilation system types within approved document F. All internal doors should allow airflow through the dwelling. The requirement is that it needs to be a free air equivalent of 10 millimetre undercut to a 760 wide door. How many new builds have you gone in where they've put carpets in and they're touching the bottom of the door? 10 mil undercut to the finished floor, 20 mil undercut to the unfinished floor. But you have to be, not you guys, but developers have to be careful, because it can, if you're putting a whole ducted system in and it can't allow flow between the 2 rooms, you could get problems. The reality is the homeowner living there will fling a door open, walk through that room to another room and the door will stay open. But if they're all shut, it could cause problems, and that's what they're saying. To eliminate that, to allow the homeowner to shut every door, put 10 mil in. We move into the next type of ventilation system, which is probably more poignant at this moment in time. Continuous mechanical extract ventilation, which can be achieved through 2 different types of ventilation systems. A combination of such is a decentralised mechanical extract ventilation, DMEV, or a continuous mechanical extract, an MEV. That's an MEV. That's how big they are. Or that's how big our one is, but some people have different shapes and sizes. And then DMEV or a DMEV. Pretty much the same little videos you saw before with the intermittent. DMEV still relies on trickle vents. The main difference is it's 24/7 as opposed to on demand when pull cords get pulled or whatever. Everything's going this way, everything's coming away from intermittent over to this. So intermittent fans are a bit of a dying breed. Another little video on the centralised unit. Same principles again. Centralised unit, ducted, return air through trickle vents, extract from wet areas. This is more of a design product. We would probably recommend, us and all of our other suppliers would recommend coming to them, getting a design done instead of just installing it how you think, because you close up a house and you've got it wrong. It's a bit late. For MEV and DMEV systems, we have to look at the high rate, the boost speed, and also the continuous rate, the background trickle rate. The minimum high extract rate is defined in litres a second for each of the wet rooms. Kitchens 13, utility 8, bathroom 8, sanitary 6. That is the boost rate, not what it runs at continuously. We and others can design a space and say what it needs to trickle at and tell you. But if that space is a big space, you might be trickling at 15 litres a second, which means the boost will be 15 litres a second. Continuous extract rates must be calculated in 2 ways, and the larger of the 2 volumes will be used. Step 1 is to obtain the rate from the number of bedrooms. Step 2 is to multiply the total floor area of the property by 0.3 litres. Should the continuous rate be higher than the minimum high rate, then the continuous rate should be used for the boost as well. There is no need to increase the speed to give any additional boost. However, depending on various factors, lifestyle, HMOs, where you've got lots of people, you might want to increase it. And if the fans aren't loud, run it a bit faster if there's higher occupancy. Background ventilators should be installed in habitable rooms, but shouldn't be installed in wet rooms. Now, window manufacturers just whack them in every window. They'll whack them in the bathroom, the utility room, and the kitchen, but you don't. The idea is you don't put them in there. The extractor fans pull out of those spaces. They draw the air from within the property, as in the habitable spaces. The habitable areas provide the fresh air. It goes out through the kitchen, the utility, the WC. If you extract in a kitchen and there's a trickle vent local to it, it'll just pull the air straight in and out. The idea is you draw it through the room and out. As you can see on there, 4,000 millimetres for a trickle vent. That's not really your problem, that's the window companies. They should be following this. They will know this, they should be following this. So you kind of got to just assume that you've got the right trickle vents. A point to consider is prevailing wind and exposed facades. This can be combated with any of these 2 points. The best solution is to use constant volume fan units. Do you know what a constant volume fan is? So constant volume fan is a fan that can detect driving wind. So if you've got a fixed grill and the wind's coming off the sea and hammering at the grill, the little EC motors in there would struggle to push harder than a 60-mile-an-hour wind. It would just stop. You'd actually see the fan impellers stop because the wind's stronger than what the fan can do. But if you get a constant volume fan, it can detect the pressure and it speeds up to maintain the extract rate. It's not on everyone's DMEV, but it's on some people's DMEVs. Right, so we're moving on to MVHR, which is probably the fastest growing type of ventilation system out of all of them. We move into the final ventilation type found within approved document F, mechanical ventilation with heat recovery. MVHR is a whole dwelling ventilation system that supplies and extracts air continuously at a low rate, with the option to increase airflow rates for boost as and when we required. The unit is typically installed in a loft or a cupboard and continued into rigid ducting, which supplies fresh filtered air into habitable rooms and extracts stale polluted air from all the wet rooms. The unit incorporates a polymer heat exchanger that recovers energy from the stale, moist air and tempers the incoming air before it is delivered into the habitable rooms. Little illustration of how it works. So wet room, air coming out, bedroom, fresh air coming in, heat exchanger back at the unit, captures the heat that you're taking out of the wet rooms, holds onto it, puts the fresh air into it, warms up the fresh air and sends it into the habitable rooms. Most manufacturers are hitting 90% on their heat recovery units. Some fall just under, some are over, but regs are cresting 73%. For MVHR systems, we have a look at a high boost rate and also the continuous rate, just as we do with the MEVs and DMEV systems. The minimum high rate is again defined in litres a second for each of the wet rooms, 13 litres, 8, bathroom 8, sanitary 6. It's very rare, those rooms, to get those flow rate changes as low as that. It's only going to be a 100 square metre house. Anything 120, 150 square metre house, you'll probably find that we will be beyond those numbers. We'll be higher than that. This slide's been repeated from earlier about the calculating bedrooms and how many litres of air are needed for a property. The mechanical extract ventilation, where the continuous supply and extract rate has been calculated in 2 ways, and the larger of the 2 volumes will be used. You can see how it goes up as the bedroom numbers go up. So that 5 bed, what they're saying is those 5 bedrooms need 43 litres a second, split across 5. The total supply airflow rates should equal the total extract airflow rates. This will allow the system to be balanced, meaning the amount of stale air extracted from the wet rooms is replaced with fresh tempered air into the habitable rooms. This applies to both continuous rate and high rate. This needs to be achieved by proportional distribution, the airflow into each of the habitable rooms. Please note, background ventilators should not be installed with mechanical ventilation with heat recovery, as they provide unwanted additional ventilation and reduce the system's efficiency. So that's quite a common question. Do I need trickle vents with this system? No, don't need it at all. MVHR should be designed to avoid the moist air from the wet rooms recirculating to the habitable rooms. Within Part F, it states that it shows examples of ventilation systems that comply. Alternative ventilation systems such as PIV, also may be used to provide it can be shown to have an equal level of performance. This may be demonstrated through expert guidance and should be included use of BBA certification or following the BSI PAS 2035, which consider it to be the most adequate means of demonstrating compliance. So yet again, this is a build that may have wanted MVHR, but the consultant has messed up the design. You can't get it in the property, and you need another means of bringing air in. There is retrofit standalone products called PIVs that can bring air into the property, but it's very rare that will go down that route. These PIVs are designed for old retrofit houses, problem solvers basically. So these are design considerations we're talking about now about noise pollution. Noise is an important consideration that needs to be addressed, as noise pollution can be a concern within dwellings. Within Part F, it states certain noise levels should not be exceeded under nominal operating conditions, not boost rates. Noise should not exceed 30 decibels within bedrooms and living spaces and cannot exceed 45 decibels within kitchens and bathrooms. Trust me, if you were at 29 decibels in a bedroom after an MVH installation, you would be getting a phone call from the homeowner. You'd be complying, but 29 decibels, even though it's within Part F, is very loud. Bearing in mind that fan there, you can just about hear it. That's about 13 decibels. So if you were sleeping with 29 decibels going, or trying to sleep with 29, it would be absolutely unacceptable. But Reg says, as long as it's under 30, so it don't take much to keep you sort of tuning into a noise. So we as designers and all our other companies, Greenwood and that, we would spend a lot of time and effort making sure that the design leaves out those bedrooms. We don't want any noise. I get more complaints about not hearing it, they think it's not working, than hearing it. Yeah, because they're in the bathrooms, they're expecting a bit more theatre and noise, and they don't get it, and they're like, is that working? Oh yeah, just trust it. To counter noise from units, there are various ancillaries that can be installed, such as attenuators, which can be utilised to reduce induct air noise in certain rooms for the entire system. Acoustic enclosures, which can reduce the breakout noise experienced from the casing of the units. Acoustic top boxes, which can be utilised to reduce overall noise on MVHR units. They also provide a neat ducting enclosure at the point of installation. Usually a combination of these will be utilised to maximise any sound reduction. Yet again, it's a design product. We wouldn't want you to go and buy attenuators. They're massive. They're big and bulky, so be careful if you're thinking you're going to chuck one in an install somewhere. As with sound, the location of the property can affect the levels of pollutants that may be drawn into the building, either through trickle vents or through supply ventilation. Section 2 of approved document Part F states that ventilation systems should be designed to minimise the intake of external air pollutants. In an area of high pollutants, it is likely that this will only be achieved by use of MVHR systems with high-grade filtration. That, if you get asked to supplement the filtration system with further filtration, as in you'll hear the word NOx filtration. I don't know if you've ever heard of NOx filtration. It's to take out petrols and gases and diesels out of the air. So if you've got a building set of flats on a busy high street, they will want NOx filtration in the system. Be very careful. That definitely has to be designed, because yet again the filters are massive. They're in addition to the filters that come in the unit, so it's two sets of filters. When you shove air through two sets of filters, there's extra pressure, which means that gets bigger because you need a more powerful one. It's a complicated thing. So if someone says to you, you've got to put NOx filtration in, put the brakes on, consult a ventilation designer, because the building very well, I've done about 5 NOx filtration jobs and not one of them has been able to take it, and they've all ended up with really low ceilings or bulkheads or all sorts of crazy ugly things just to get them in, because the consultant hasn't deviated. He said no, they're going in. And you've gone from having the architect wanted a 2.6 ceiling in this beautiful flat to like a 2.3 ceiling, because we've had to put a bloody great filter box in with an inspection hatch and everything. It's not great fun, and they have to be changed every 6 months, the filters. And the filter box costs £1,000. Not the filters, the filter box, but the filters are still a couple £100 every 6 months. So none of these consultants who just go put NOx filtration in, none of them work all this out. They don't care. No, but it will be your problem, which will then be my problem or someone else's. So just be mindful that if someone goes, oh, I've been told this house needs NOx filtration, just go, whoa, let's have a look at this first. NOx filtration may need to be considered on city centre developments or where lower level dwellings are next to busy carriageways, again only applicable to systems that provide supply air rather than background ventilation. It should be noted that adding such filters will add the pressure loss to the system, and these filters will need access for routine maintenance. Mechanical ventilation systems must be commissioned by a competent person and notice given to the building control body. There is a SAP benefit when the ventilation system has been installed by a competent person. To become a competent person, you can attend a training course, for example an NIC/EIC domestic ventilation course, which is delivered by various training suppliers. An installation comprises of many components, many of which specified within Part F. Within Part F, it must be ensured that the system can be accessed to maintain the equipment and ensure that there are no obvious defects and all packaging has been removed. Example of a good installation where the unit is accessible, similar to the image on the left. Now, before you say anything, that's removable. That is just there. Because everyone goes, well, that's not very good. That comes out. Compared to a poor installation where the unit isn't accessible to all, shown on the right. That is actually spanning 2 floors. There's nothing I've seen or done or dealt with, but that is from one of my colleagues. I mean, they've got a condense on the bottom, so there's something. It is suggested that rigid ductwork should be used wherever possible, designing to minimise the pressure losses to ensure efficiency and sealed to prevent any leakage. Examples of a good installation with each connection sealed properly compared to a poor installation where flexible duct has been taped together with parcel tape. Regulations up till 2022 said no more than 1.5 metres are flexible on any installation. That was the regs. Then they changed it to minimise where possible, which is very ambiguous. So essentially an axial fan, whether it's that one or anyone's axial fan, which is just an intermittent fan, is only designed to go through a cavity wall. And the pressure losses over 350 mil, including the grill on the back, the grill will drop it by 15%. The sleeve will drop it by about 15%. That's why that fan starts life as a 28 litre fan. By the time you put the sleeve and the grill on, it's down at 20. If you buy a fan off someone's shelf that has a starting life of 18, 19, 20 litres a second, by the time you put the sleeve and the grill on, it probably fall below the 15 that you've got to hit. So be very careful. Not that they're getting monitored and you're being told to do a certification for one of them and things like that, because the reality is no one's policing it, and it is going to do something. But if you want to do it properly, solid 350mm sleeve on that. Other than that, you should be on to a DMEV because they can handle the pressure. Flexible ductwork should be kept to a minimum and ensured that the ductwork is taut, not sagging, nor is it tight, nor has any tight bends to ensure system efficiency. As you can see from the images, the ductwork should be straight and have long sweeping bends where possible, not tangled with multiple bends as per the image on the right. Airflow rates of all installation systems should be tested and recorded with a commissioning checklist. Correct equipment should be used to measure the airflow rates, which is an airflow device that has been calibrated in the last 12 months at a calibration centre accredited by UCAS. Anemometers with a hood on it. By regs, every single fan you should be going anemometer, 15 litres a second, signed Joe Bloggs Electrical, submitted. The reality is, when that goes to the homeowner, that's where it ends. There's no building control. If it's under building control, they're getting more and more and more involved. They definitely will be all over you for this, but the Boggo fans, there's not enough time in the day to police all of them. I cover Kent, Sussex, Surrey, bit of Hampshire, and the differences of interpretations of this is mental. Is absolutely mental. And I do say to contractors when they ring me up, I've got this job and they want me to do this, they want me to do that, and I go, where is the job? Kent, yeah, you'll be all right with that. Or Sussex, they're not going to go with that, because they're all different. In some scenarios, the configuration may prevent airflow from being measured. In these scenarios, you will need to determine the airflow rates as per manufacturer's guidelines. As per Part F, there is a compliance checklist that needs to be completed, which was previously part of the Domestic Ventilation and Commissioning Guide and can be found within Appendix C, and Part 1 is shown on the slide. Part 1 contains the particulars of the system, address of the installer. Part 2 is the installation checklist. Part 2B is a visual inspection or pre-commissioning checklist. Part 3 is for recording airflow measurements and from fans. All sections will need to be completed in order to demonstrate compliance. ADF and L now require a home user guide to be provided to the homeowner in the handover pack. It needs to be a non-technical overview for occupiers and should include some basic details on the operation and maintenance of the system. National Ventilation offer a full suite for homeowner guides which can be used to fulfil this requirement. Most manufacturers have a guide for their products. I can't imagine many homeowners wanting a guide for a through-the-wall fan. They just want to make sure it's working, but they are all available. And we've reached the end.